Let us see the independent events now. Two events are said to be independent of each other if occurrence or non-occurrence of one event has no effect on occurrence or non-occurrence of the other event. So that means literally the two events do not have any impact on each other. They are called as independent events. So mathematically what does this mean is, see, A and B are called as independent events if and only if probability of A intersection B is equal to probability of A into probability of B. So if this condition is satisfied, only then we call the two events as independent events. Now we have to note one important thing, that if A and B are independent, then the following pairs are also independent events, that is A dash and B dash are also independent events, A and B dash also are independent, and lastly A dash and B are also independent. So basically all four of these pairs are independent events. So given any one, the remaining three automatically follow. Now let us solve one question based on the independent events. The probabilities of two students solving a problem independently are 1/4 and 1/5. Find the probability that the problem is solved and find the probability that exactly one person solves the problem. Now let us translate this into symbols. Let's call the probabilities of two students solving the problem as say A and B. So if we consider the first probability as say P of A, that is equal to 1/4. Okay, so A means person A has solved the problem, right? And secondly, P of B is given to be 1/5. So that means second person B has solved the problem, right? So that is 1/5. Now if we look at the first question, that is problem is solved. Now the question does not say by whom, so that means we have to consider any general possibility, that is A may solve the problem or B may solve or both might solve. So that means in general we want to consider the union of the events A and B, right? So that means what we want to find basically is probability of A union B, correct? Now we know that probability of A union B is given by the addition theorem, that is probability of A plus probability of B minus probability of A intersection B. So therefore let us write that. Here we have probability of A plus probability of B minus probability of A intersection B. Now for the first two probabilities we have the values given directly. So therefore we will substitute the values of those probabilities and we get P of A is equal to 1/4 plus P of B is equal to 1/5 minus, now P of A intersection B is not given to us directly, but it is mentioned that the two people are solving the problem independently. It means whether or not first student solves the problem has no impact on whether or not second student solves the problem. So therefore this is a case of independent events. So therefore as per the definition, probability of A intersection B will be nothing but probability of A into probability of B. So here therefore we multiply the two individual probabilities. So that is nothing but 1 by 4 into 1 by 5. Right? So this is what we have to calculate. So that is further equal to, now let us see that the denominator throughout will be nothing but 20. Okay, so let us write the denominator as 20. In the numerator, first we have 5 plus next we have 4, and from the last term we have minus 1. So that gives us 5 plus 4 is 9 and 9 minus 1 is 8. So 8 by 20 is nothing but 2 upon 5. So therefore that's the probability that the problem is solved. Now the next question is, we have to find a probability that exactly one person solves the problem. So it means that if A solves the problem, then B should not solve the problem. So that means we have to take the event such that A solves, but, now here the but means intersection operation. That is, we want A to solve the problem, but we don't want B to solve the problem. Therefore we will have B complement along with A. Now another possibility is that A may not solve the problem, so therefore here we have A complement, but B may solve the problem, so therefore we will take intersection B. And we connect these two probabilities by addition, because it is either the first possibility or second possibility, but both of these possibilities cannot occur together. So therefore we have to consider the addition of these two. Now as we have seen earlier, if A and B are independent events, then A and B dash will also obviously be the independent events, and similarly A dash and B will also be independent events. So therefore here P of A intersection B dash will be nothing but P of A into P of B dash. Alright. Now out of that, P of A is given to us, which is 1 upon 4 multiplied by. Now P of B dash will be how much? If we see this, P of B is 1 by 5. So therefore P of B dash, that is B complement, will be nothing but 4 by 5. That is the first term. The second term is, similarly we split the P of A dash intersection B as a product, that is nothing but P of A dash. Now here P of A is 1 by 4. So therefore P of A dash will be nothing but 3 by 4 multiplied by P of B will be as it is, that is nothing but 1 by 5. Now here in these types of sums, in the first term we may be tempted to cancel 4, alright, but do not cancel that, because you see the denominator is 4 into 5, which is common in both the terms. So therefore let's keep that as it is. So therefore numerator is 4 and 3. So when we add those two, we get 4 plus we have 7 divided by the common denominator is 20. So therefore the required probability is 7 by 20.